Alright, here is the instructional YouTube video for section 6.4 part B. We're talking about exponential decay functions. Instead of exponential growth, it's exponential decay. So we need to remember for an exponential decay function, so I'm going to write that up here. If we have exponential decay, the equation is y equals a times 1 minus r to the power of t, where a is the initial amount, the starting amount. So a right here is the initial amount, and r is the decay rate as a decimal number. T here is the time interval. So like t could represent days, weeks, months, years, whatever it represents. Like if it's in years, if 5 years have gone by, you put a 5 in for t. And y is basically like your final amount. Right, the initial amount is here. You multiply by what we call this whole thing is the decay factor to the t, where t is the number of time intervals that have gone by. Once you do that, you get your final amount. All right, so looking at this first problem, the first problem we want to look at is we have this equation y equals 12 times 0.895 to the t. And we want to find the rate of decay, r, and the initial value, a. So basically I'm looking at this equation. I'm saying, okay, this number right here is less than 1. Remember, if the number we're multiplying by is less than 1, our answer is going to get smaller. Right? Because this number is always going to be a positive number. So we don't talk about negative numbers to exponents. It's weird for functions. We don't do that. So here, if this is less than 1, we're talking about decay. So we have an exponential decay function. And we want to know, well, basically, what part lines up with what in our general formula for exponential decay. So we want the initial amount a, that's the number that's multiplied outside of the parentheses. So here, our initial amount, a, is 12. So we'd say a equals 12. That's the initial amount, right? Also like the starting number, if this were a word problem. And then if I want to find r, the rate of decay, I look right here. The r in our formula is right here at 1 minus r to the t. I have this number instead of 1 minus r. So what I'm going to do is I'm going to look at this 0.895, and this is one way to do this problem. And I'm going to say that equals 1 minus r. And now I need to solve this equation for r. And I want it as a percent. We'll get to the percent later. So what I could do is I could go, well, I've got a minus r here. I can add r to both sides, and then I can subtract 0.895, and I would get r equals 1 minus 0.895. Now, because there's nothing really special about the 0.895, it's just a number. No matter what this number is, as long as this is a number that's less than 1, or sorry, between 0 and 1, I can always do this. Whenever I'm finding r is going to equal 1 minus whatever this number is. Whatever number is in the parentheses. If it's exponential decay, r equals 1 minus that number. If it's exponential growth, it's that number minus 1 to find the rate. But because it's decay, it's 1 minus that because of where the minus is on the r. So here I go 1 minus 0.895. That is going to be r equals 0.105. And it's asking not as a decimal number, but as a percent number. So whenever I'm taking a number as a decimal, like 0.105, to turn it into a percent, I need to multiply it by 100%. So what I do is I take this 0.105, 0.105. I multiply it by 100% to change it into percentages, and that gives me R equals 10.5%. So what this equation is saying, right here, is you start out with 12, whatever you're talking about. Let's say it's 12 grams of bacteria in a tray or something, I don't know. And you're losing 10.5% of that 12 every t time intervals. Or another way to think about it is you're keeping 89.5%. Losing 10.5% is the same as keeping 89.5%. Okay, so that's that problem. The initial amount is a number in front of the parentheses. If I want to find R as a percent, what I do is I go 1 minus whatever the number is inside the parentheses there, because it's just generalizing this equation. So I go 1 minus 0.895. That gives me a decimal number, 0.105. And then I turn it into a percent number by multiplying it by 100 to say the decay rate is 10.5%. All right, let's look at problem 2, and then that'll be it for the video. So here we want to write a function, write an equation for a situation where the value of a $30,000 truck is decreasing by 4.5% each year. So we're going backwards, kind of, from what we did here. So here I'm just going to start out and say, well, this is what my equation is going to look like. I have y equals a times 1 minus r to the t. And I got to plug in what's my a value, what's my r value, and so on. Well, that's it, not so on, that's it. So I say a is the initial amount. Well, the initial amount here is the value of a $30,000 truck, so the truck starts out at a $30,000 value. Right, because trucks are expensive. That would be an inexpensive new truck, really. They get really expensive. That's why I drive a Prius. So $30,000 is my A value. That's going to go right here. My R is 4.5%, because R is the rate of decay, but I want it in my equation as a decimal number. So I got to do the opposite. Remember here, to turn it into a percent, I multiplied it by 100. If I'm going from a percent to a decimal, I need to do the opposite of this action. This action was multiply by 100%. The opposite of that would be divide by 100%. So I'm going to go 4.5% divided by 100% to get rid of the percentages. And this is going to give me 0.045. So R as a decimal number is 0.045. So I'm going to write my equation. Y equals 30,000 times 1 minus 0.045 to the t. Okay, cool. But that's not my final answer, because I can simplify this. I can subtract 1 minus 0.045. So I do that subtraction. I get 0.0955. And I get my final answer, which is y equals 30,000 times 0.955 to the t. And there we go, we got it. That's our final answer. When the truck loses 4.5% every year, what it's doing is, instead of keeping 100% of its value, it's keeping 95.5% of its value. And that's what this 0.955 represents. And then what we would do if I want to find, like, after 10 years, what's the value of the truck? I would go 30,000 times 0.955 to the 10th power. So really, if we were doing this without a calculator, which we wouldn't, we'd go 0.955 to the 10th, whatever that is, and then multiply it by 30,000. Okay, hopefully this helps you out with the 6.B, oh my goodness, I said it again, 6.4 Part B homework assignment. If not, let me know. Remember, I got office hours. Thanks for watching.